Welcome to the Tektronix VQS1000 Video and Audio Quality Software Overview. My name is Dennis Kucera, and I'll be spending the next several minutes providing an overview of this application software. A couple of the requirements that we have is that the streams, whether they be in file mode, connecting from a switch or from an MTM, be encapsulated in a transport stream format. Another requirement is that the video be of type MPEG-2 or H.264. Here's an example of a video clip that we've captured, and it shows a standard definition video with low bitrate encoding and no filtering, and as the high motion objects come past, an example being the runner's arm, there is overcompression. As we zoom in to the runner's arm, we can see that the pixels of size 16 by 16 making up a macro block have distinct edges on their sides. Those are the sides that we will be looking for with the VQS software. The software is installed on a Windows PC. It can be used to analyze a pre-recorded transport stream file, video directly coming from an IP switch, or backhauled from an MTM400. Here we have the VQS1000 application. In the upper left-hand corner, we have extracted the metadata to view what's in the video and the audio elements. In the center, we have our trend plots showing our audio and video measurements. This example shows frozen frame and blockiness. We can also provide more measurements on this display, including audio loudness, the right side showing loudness in LKFS or dBFS. We also have our meters, which show our 4 video and our 4 audio measurements, as well as any events that occur. In the lower left-hand corner, we have our decoded video with its measurement region. The right shows the measurements from video motion, black, blockiness, and also our audio levels. We also want to review the event information and how it's triggered. We can set the alarms for a particular threshold, in this example for frozen frame, when the frozen parts of the video are above 90% and last for more than 5 seconds, a triggered event is occurred. Another important feature of the VQS is the logging of the measured video and audio. Every 60 seconds of the measurement graph has its maximum, minimum, and mean information written to a comma delimited format file. Here, opening the file, we can see that for the last 16 seconds, we have been writing 1-minute logs for all of the video and all of the audio measurements. Another important feature is when a triggered event does occur, you can write a transport stream file to the hard disk. It can be of any size, starting at 10 megabytes. It can also have the triggered event in the center or anywhere from the beginning to the end. Also, the events can be triggered from blockiness or any of the 8 measurements. Now let's begin by opening a transport stream file. The first thing it does is open the file, search for the patent PMT, and begin making measurements on the video and audio elements. In this example, we're measuring all of the video and audio elements and displaying the frozen frame, audio loudness, blockiness. Here we have the audio levels for the MPEG audio that's being measured. And now let's switch to the real-time mode, which is an important part. We have 2 network interface cards in this computer, and we can choose either of them. We can also select from IGMP or from a fixed port. In this example, we'll select the network interface card, and then we will go to the stream selection because there are multiple IP sessions on this network interface card. In this example, there are 3, and we'll go ahead and select the one ending in port 8001. Now we've selected that one video program out of all 3 of them, and we are now making live measurements on that video and audio element. Here's the blockiness of that live transport stream. Now, another important feature is to be able to make measurements from a remote probe, such as an MTM400 or an IPM400. In this example, we'll switch to the remote user interface. In this case, it's an IPM400, and we'll select one of the multiple IP sessions, in this case 8001. And once we have that identified and we are decoding the transport stream, what we will do is select the play button, which will automatically spawn the VQS application software and begin looking for video from that remote probe. Down at the bottom of the screen, we can see that we are connected to the MTM located at net 39.91. At this point, we are now making measurements on that live transport stream. This concludes the overview of the VQS1000. Further videos will include advanced analysis and advanced audio measurements.